Hello everyone. So today we are going to simulate the distance vector routing using the RIP protocol. So routing protocol is basically a, a mechanism by which we can able to send a packet from the source to destination. We know that the entire internet is uh, divided into many autonomous system. Autonomous system is basically a collection of routers and networks that is controlled under one administration. So if we are doing any routing inside any autonomous system, it is called intra-domain, and within the two autonomous systems, it's called inter-domain. So RIP is a protocol that actually which is based on the strategy to do the routing inside the autonomous system. So we'll see that how it actually works. So in this simulation, we are going to create three networks. As you can see, these are the three networks we have created, and then we will connect these three networks with one path and then send a packet from this network. Any machine from this network will deliver a packet to this network, and then later we will add one more path, and then we will realize that router will automatically identify that which is the best path to do the delivery in an optimal way. So let's start. Okay, so this is the Cisco packet tracer environment. So as we have seen that in our simulation, we need to create three networks. So let's just create three networks. So the first network is having two PCs. So I'll take two PC here, and then we have second network, then we have third network, and then these need to be connected. So let us connect this with the help of switch. We'll take this switch, but then also we need some routers in order to form this internet. Okay, so this is done. Then we need to connect this all. So let us take this cabling. We'll do cabling, and we'll take this automatically connection type we will choose, so that it will automatically determine which type of cable is required to connect these devices. Okay, so let us uh, give a formal shape to it so that reflects like a network. This is one network we are saying, this is another, and this is the third one. And then we need to assign the IP. So as we have seen that this is the network of class C. So let us 192.168.10 series we are taking. This is a uh, network ID for this network. So we'll give the first IP to the router 10.1. This we're giving as 10.2. This is series 20. Okay. After that, we need to also connect these routers together. So again, we will use cabling. So for this, we will use, let's say, class A address. Let's say 10.0.0.1. Okay. So this will be 10.2 for this port. This is class 20.0.0.1. Dot 2. So far, it looks good. We have give the basic configuration to the entire network. We have given, so we have just actually identified what IPs to be assigned to these devices, but actually we have not configured it. So now we have to configure it. So this PC is having this 192.168.10.2. Default gateway is this router 10.1. So you can see here, this is now assigned 10.1, gateway is 10.1, and IP is 10.2/24 class C. Okay, okay. Then for this is network 20. So okay, and default gateway is 20.1. Okay, then similarly we can do it here also. This is 30.1, sorry, 30.2 subnet mask, and default gateway is 30.1. Okay, so we can just hover over it, and then you can see that okay, this is defined. Here it is, address is defined, and this is 30.2. Fine, and the gateway is 30.1. Okay, so what else left? Now we have to configure the router as well. So here you can see that if you just hover here, and you can see that this is a serial port, and this is a fast Ethernet port 0. Okay, so we'll go here, and then you can go to configuration. Then for this port is basically the fast Ethernet 0, then go here, and then this is 192.168.10.1, and we'll keep the port status on. Similarly, you can see this is a serial port which is visible here. If you can see here, this is just you can hover here and you can find that this is a serial 2. So you can go here, and here you can just configure it. This is 10.0.0. This is done. Similarly, we can see this is uh, just have a look. This is a fast Ethernet. This is SE3, and this is SE2, right? So fine, we can go to configuration. This is this one. Here you can write 192.168.20.1 should be on, and then this is the 2. This is 3. This is 2. Okay, so 3 configuration. This is okay. So you can see here that serial 2 up is up, serial 3 is down, serial 3 is this one. So let us first configure this one, then we can see that it will also become up. This is SE2. Okay, this is 20.0.0.2. Okay, so now we can see that all the devices are configured, ports are on, and you can just verify that the link is up or down. So here it is up, up. Here we can see that 3 links are up. Okay, here we can see that 2 links are up. Okay, so this is done. Now if we send a packet to see what will happen. Let's say this is a packet to be delivered from here to here, and you will see here this is failed because we have not yet set the any routing information here. So let us do the RIP. So we'll go to the router, and then we have to tell the routers that who are the neighbors. So in the RIP, we are telling that initially we have to tell that who are the neighbors, and then so in the entire RIP, the communication is happening within the neighbors. So we need to inform that the neighbor of this is this network, and means that the neighbor of this is this network and this router. And for this also we have to inform about these 3. So let us update this information in the router. So we'll go to the RIP, and in the RIP we have to inform that this connects to 192.168.10.0 network is connected with this router. We should add this. Also, this connects to this network. Okay, then we similarly do the same thing here. We will give the information of the neighboring routers and to the ports which it connects. So it connects to 20.0 and it connects to 10.0.0.0 and it connects to 10 dot sorry 20.0.0.0. Okay, similarly we will do the same thing for this. Connect to 192.168.30.0. Along with this, it also connects to 20.0.0.0. Okay, so now I believe everything is configured. We have already implemented the RIP in this network for the routing. Now see what is happening. So again, we will try to send something from PC1 to PC4, and you can see it still failed. So let us verify what we have given here. So here we have given 30.1, okay, and 20.0.2. This is correct. What about the RIP? RIP is this network 30 and 20. This is correct. So we can see here that now it's successful. We can also demonstrate and visualize that how uh, the packet is to be transferred or routed. So we'll take one packet again here and then we go to simulation mode. We did here and send it here, and then we see the simulation that how the packet is being traveled. So and we see the packet has been routed to the destination. Okay, now we will do one change here and realize that how actually the RIP works, how these routers keep on updating their information and find the optimal path. So in order to uh, realize this, let us uh, make some changes here. Okay, so what I will do is I'll just connect these two routers together so that now we'll have a new path. So let me connect these two routers. Now if these two networks want to communicate, then we have two possible paths. One is through one hop, two hop, and then is the destination. Or you can just take one hop and go to the destination. So if the protocol is working correctly, then when you are sending something from this network, it should take one hop and then reach to the destination. That we have to see. So let us first configure this. So we will take this is 10, 20. We'll take another network of class A, that is let's say 30. So okay, this is 30.0.0.1. 30.0.0.2. Okay. So the network, you can say it is a 30.0.0.0 is a network, and then we have used two ports to connect these two routers. Let us configure this as well. So here you can see this is SE3. So you can go to SE3 and then just give this configuration. This is 30.0.0.1. Similarly, we do the same thing here. And this is SE3 as well. This port we will be 30.0.0.2. Okay, so we have configured these routers, but we also have to update the IP because now this router has. So earlier we have shown that this router has a connection with this network and this network, but now we have to also update that this router has one more connection, which is 30.0.0.1, which is 30.0.0.0 network. So we will update the RIP information here. So we will just add here uh, 30.0.0.0 is also one network to which it is associated or attached. Okay, and similarly we can do it here. So this is go to the RIP and then we add the network here. This is 30.0.0.0. Fine. So I hope that we have successfully configured the entire network. Now let's send a new packet, or let's see the new communication and see how it will be routed. So we'll take this and try to deliver it to here, and then we also simulate this and see that how the packet is being routed to reach to the destination. Router itself determine that which is the best path to deliver any of the packet, and we have seen that now it has followed a new path because the new path comparatively is better than the previous one. This is all that we need to demonstrate in this RIP. So I hope you have understood that how the RIP works. That's all. Thank you very much. See you in the next protocol LSR.